Good morning, all of you. So, in yesterday's class, we have learned real depth, apparent depth, and shift. Now, today we will continue that. But if suppose it is near normal incidence, then how to solve or which formula we have to use, that we are going to learn basically in today's class. Okay, so let's start. Apparent depth and shift. Apparent depth and shift of submerged object. Near normal incidence. That is what? Small angle of incidence. So apparent depth and shift of submerged object near normal incidence means what? First of all, let me explain. See, if suppose this is rarer medium and this is a denser medium, and suppose object is here and this is what your incidence is. Near normal incidence means nearly normal. Incident ray is nearly normal. Then we can say that that is what near normal incidence, or even like this also. Very small angle. Very small angle of incidence, even like this. Okay, this angle. So then we can say that that is near normal incidence. Okay. Then how to find real depth and apparent depth and all these things that we are going to learn in today's class. So first of all, apparent depth. First one is what? Apparent depth. D dash is equal to real depth divided by n relative. N relative. So n relative is what here? Here n relative is equal to ni divided by nr. Ni is what and nr is what? So ni is refractive index of medium of incidence. Medium of incidence. And this one nr is what? Refractive index of medium of refraction. Medium of refraction. So if I am using this again formula, so substituting these values in relative here, so what we are getting, d dash, therefore d dash is equal to d divided by this n relative value is what, ni by nr. So I am substituting here ni divided by nr, and therefore if I am transferring this side, so I am getting like this, d dash is equal to nr into d divided by ni, and d dash divided by nr is equal to d divided by ni. है ना? So this is what your formula you got in between real depth, apparent depth, and refractive indices of two mediums. One is medium of incidence, another is medium of refraction. Got it? Yes. So you can use this formula. Next one, that is apparent shift. In this case, which case? This one, near normal incidence. So shall I write here number 2? Let's give it as a number 2 because already I given as a number 1. So this is number 2. Apparent shift. If you want apparent shift near normal incidence, this is all the cases are near normal incidence. Whatever yesterday's formula was there, that was for not near normal incidence, that was having some angle of incidence and angle of refraction. But here it is near normal incidence. So if you want to find apparent shift near normal incidence, then its formula is equal to d, that is real depth, into 1 minus 1 by n relative. Okay, which is what your apparent shift, right? So this formula you can keep it in mind. This is for apparent shift and this one is for real depth, apparent depth, and this refractive indices. Okay, let's solve one problem of this near normal incidence, whatever model we have finished today. So let's solve one problem. How they are asking problem, you see. Very nice problem actually they are asking on this model. An object lies 100 centimeter inside water and they have given refractive index of water is equal to 4/3. Okay, it is viewed from air. It is viewed from air nearly normally. So see, this is what this word is very important. Nearly normally means normal incidence case only you have to consider. And he is asking, find apparent depth apparent depth of object. Find apparent depth of object. Okay, so let me draw one rough diagram for your understanding. Now this is the interface, and let us suppose object is like this. This is object, and I have placed here object like this. Okay, this is object here. Can you see? This is a object. This is object, and now this is what you have to find. Apparent depth you have to find. Okay, they have given this also. This is how much? This is 100. Then this one they have given how much, that is 100 centimeter. This is your d value. This is real depth. D is equal to 100 centimeter. And now somewhat you are looking, yes, you are looking this object nearly normal incidence. Okay, what you are doing? You are looking. This is, I am keeping it as a dot 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 lines because you are going to look from here. This is your eye. Right? Yes, you are going to look from here. Okay. So this is what you see normal incidence, and you want to find d dash because it will appear a little up. So you want to find d dash. D dash is equal to how much? D dash is equal to question mark. And this is what air. For this refractive index is equal to what we are taking, nearly 1. And here it is water. Yes or not? This is what? Water. Can you see? So this is water, and its refractive index also given, mu w is equal to 4/3. So everything is given. So let's, I think now you understood the problem. So let's start solving. Okay. So we have learned just before some time formula, that is d dash is equal to d divided by n relative. Okay, and that is equal to d divided by n of incidence divided by n of refraction. Okay, now incidence means what? Ray will go from water to this, so keep it in mind always. Incidence means not always what we can say air, because ray will come from down, understand, from water it is coming and it is reaching to our eye. So here ni is equal to nw is equal to 4/3, and n of r is equal to n of a is equal to 1. Keep it in mind this one. So therefore d already we have how much? This is 100 divided by ni means what? nw. nw is equal to what? 4/3 divided by 1. Okay, and then you are getting this is equal to 300 by 4, and therefore d dash is equal to 75 centimeter. 75 centimeter. Understand? If you want one more step, you can add here, that is d divided by nw divided by na. So object will appear somewhere here. Yes or not? It is commonly experienced example. You keep a coin inside a water and you try to see from air. The coin, you will appear that it is raising. It is not that at that much depth as it is actually present. Isn't it right? So like that you have to find just apparent depth. Okay, so this is what one simple problem on this model which is of normal incidence. Okay, so let's solve one more problem on this model only, important problem, so that you will understand everything. So let's see. They have given first diagram, so let me draw first diagram only. So this is water, this is a water, and inside there is a fish. Okay, fish is inside the water. Okay, and now bird is here. Something like this. Okay, bird is here. Okay, and it is not in the air. Okay, it is flying. Is it looking like a flying one? No. Wait, let me draw again. It is looking like a crow, right? So let us suppose something like this we will make. Let's make something like this. Something like this. Not important that much diagram. Okay. This is not drawing class. Okay, whatever it is. This is just bird. Keep it in mind like this. And now this bird will go in the water and it want to eat the fish. So when it is watching from air, this fish, it will, for this bird, it will appear little up. It will appear little up, isn't it, right? So how to find at what depth it is there inside the water? Let's calculate. Okay, let's calculate this one. So before what he has given, let's note down once in the problem what he has given. So he has given refractive index first of this water. So they have given mu W is equal to 4 by 3 as usual. This is air and this is mu A is equal to 1. And then they have given this distance as a 36 meter. And even this distance also how much? 36 meter. How much this distance? 36 meter. And this distance also 36 meter only. Same distance from the interface. Okay, water, and this is air, bird is there, fish is there. And now what is the question? See what they have asked in question. Number A, find apparent height of bird. Find apparent height of bird. Okay, apparent height of bird means for whom? For fish. Fish is going to look the bird. So at what height bird is there? Who should understand? Fish should understand. So this should be with respect to fish. Keep it in mind. Second one. Apparent depth of fish. Find. This is with respect to whom? With respect to bird, because bird is going to watch that. Apparent depth of fish. Okay. Next, third question or third bit we can say. At what distance? At what distance? At what distance will the bird appear to fish? Will the bird appear to fish? And last one, at what distance will the fish appear to bird? Appear to bird. Okay, this is what the question they have asked. Right, so let's start solving. So I'm starting from question number 1. So I'm making some 2-3 columns so that you will understand and we can finish problem. This is 1. This is second column. This one just for my solving problem. Okay, and let's make this as a fourth bit we can say, so that we can solve this problem on one page. So that because already diagram is here, no? So let's move ahead. Now a bit. I am solving a bit. Everything given is what already I have mentioned here in the diagram. So apparent height of bird. So here, can I denote this as a like this db dash? So db dash is equal to what? D divided by n relative, our common formula. This is for nearly normal incidence. Keep it in mind. Nearly normal incidence. So here now, this is equal to D divided by n relative means what you will get here? N relative, what you will get? N air by N W. Keep it in mind. This is, once this you understand, then it is very easy for you. Right? So this is equal to D divided by 1 divided by 4 by 3. Keep it in mind. 1 by 4 by 3. So what will come up now? 4 will come up, right or wrong? So this is equal to D. Already you know how much D? 36 divided by 1 by 4 by 3 means this is nothing but what? 3 by 4 shall I write? 1 by 1 by 1 by D by 1 by 4 by 3. So you are getting directly like this 3 by 4. That is equal to 36 into 4 divided by 3, and therefore dB dash is equal to, this is 12, and you are getting 48 meter. So see how much how much great politics nature is playing with one another. Yes or not? For fish, bird will appear little long or near little long as compared with its actual position. So that is what politics, right or wrong? So which nature is playing with that. Similarly, for fish also same thing. Okay, so let's see. Let's first calculate this, then you will understand how the survival of the fittest or how nature protecting one another. And if you want to kill someone, you should be superior than the one to whom you want to go or you are going to kill. That should be there, right? So see, this is B point I'm going to tell now. Find apparent depth of fish now. So this is again df dash is equal. This is for fish. D divided by n relative, same formula. So therefore df dash is equal to D divided by, now what you will get here, NA by NW or NW by NA? NW divided by NA. Okay, NW by NA. Because who is fish is inside water? No, that's why. So therefore here you are getting 36 divided by NW is how much? 4 by 3, and Na is what? 1. 4 by 3 by 1 is nothing. So you will get here 36 into 3 divided by 4. This is what? Df dash. And how much it is? Yes, tell me how much it is. 27. So see now, for bird also, actually it is at 36 meter, but it will appear how much? 27 meter. Yes or not? How much it will be? 27 meter for the bird. Is that clear? Understand? Okay. Now, see bit. For the fish, at what distance will the bird appear to fish? So for this fish, this is 36 plus actually how much it will appear? How much it will appear? 48, yes or not? So 36 plus 48, how much? 84, right? So see, I am writing here. For the fish, bird will appear, bird will appear at a distance, that is distance of bird is equal to this 36 plus how much it is? 48. Yes or not? Because that is apparent for the fish. So therefore you are getting distance of bird from the fish is equal to 84 meter. So this fish will feel that bird is very long, so happily he will enjoy inside the water, but suddenly bird will come down and it will eat to the fish, right or wrong? Understand? Okay. So next last point, that is D. For the bird, the fish will be observed at, for the bird, fish will be observed at here also we will keep observed only, not appear. You can keep but not an issue. But I'm writing here observed, so you can write here also observed only. So observed at. So for the bird, fish will be observed at a distance. How much? Distance of fish is equal to, this is for bird is 27 and this is 36. So 36 plus 27, how much? 36 plus 27 is equal to 63 meter, and therefore distance for the fish, distance of fish for the bird is equal to 63 meter from the bird. It is appearing, है ना, or observed, but actually is 72. Understand? This is what effect of apparent depth. Understand? Okay. So note down carefully. Try to understand. Hmm? If you have any doubt, please ask me. Note down this. Okay. So let's stop here for today. And this part also, if you want to note down, you can, as well as this also. If they are asking apparent shift, you can find out by using this. Okay. So bye for today.